Welcome, Dr. Ganguly. It's been a pleasure, and I appreciate your time for us, allotted for us. Let me cut back and because we have a young generation viewers, I just want to know one simple thing. How did your family react when you said that you're going to work with plutonium, which is supposed to be such a great element?
Okay, first of all, thank you for arranging this podcast. And plutonium is an exotic element. It does not occur in nature, as you know. It is artificially made in a nuclear reactor with uranium. Uranium occurs in nature, and the two isotopes of uranium are U-235 and U-238. 99.3% U-238 and 0.7% is U-235. So when you bombard U-238 with a neutron, then it captures the neutron, becomes U-239. It undergoes beta minus decay, becomes Neptunium-239. Again another beta minus decay and becomes plutonium-239. Now the plutonium-239 half-life is nearly 24,000 years. So you can say that it is more or less, I would not call it stable, but metastable type of isotope, which is a long half-life. Now plutonium has got all the properties of U-235. That means it is a fissile material. That means if I bombard plutonium-239 with a neutron, then it will undergo fission and it will generate enormous amount of energy. As you know, per fission you get about 200 million electron volts of energy. If you compare with the carbon, suppose when I burn a carbon atom, at the most I will get 4 electron volt. So 200 million electron volt for U-235 or plutonium-239 and only 4 eV for carbon. So this energy, high energy density, this has been exploited by human being to the maximum. The thing is, plutonium is also highly radioactive and radiotoxic.
Correct.
If you see, the maximum permissible body burden of plutonium is only 0.6 microgram.
Okay.
So plutonium cannot be handled in the open. It has to be handled inside leak tight globe boxes or hot cells, which are often shielded with the beta, gamma and neutron, and inside that you will have to handle the material, and the globe boxes and all the hot cells, they are maintained under a negative pressure. So ventilation is equally important. So as I told you, this material is very exotic. In the earlier years, it was discovered in 1940 by Seaborg and his colleague in the University of California, Berkeley. Immediately after that, it was used for weapon program. And as you know, the first weapon was tested, the only weapon tested in New Mexico desert was plutonium-239 based. And then the next month in August, as you know, it was in Nagasaki, that bomb was dropped. So that stigma is in the back of everyone's mind that plutonium means bomb.
Correct.
But the peaceful uses of plutonium are enormous. I mean, and this could be used as a very good fissile material, particularly for fast neutron reactors. In the fast neutron reactor, you use plutonium in combination with U-238. And in the process, you breed more plutonium than you consume. And with that, practically all the natural uranium resources can be fully utilized. And to share with you something very important, the total natural uranium identified in the world is about 8 million tons at a price of less than $260 per kg. This identified uranium and also uranium in the rock phosphate and in the shale, if they are effectively utilized in water-cooled reactors followed by fast breeder reactor and with multiple recycling of plutonium and uranium, then you can meet the entire energy requirement of the world for tens and thousands of years. You don't need any other form of energy. So plutonium is very essential for long-term sustainability of nuclear power, and particularly we have to use plutonium in a fast reactor in combination with U-238 and in closed fuel cycle. So this is when we hardly had any information on plutonium, because not only my family, I did not have, but I was very fortunate to join the best group in BARC, Radiometallurgy Division, under the leadership of Mr. P.R. Roy, who is no more, late P.R. Roy. And at that time the director was Dr. Raja Ramana, and the director of the materials group, nuclear goods, of P.K. Anger. We got lot of encouragement.
Yes.
They were great men. Encouragement from them. They gave us lot of free hand. They allowed us to make mistakes, learn from the mistakes. So this was very exotic for me, but my family had hardly any idea, and at that time I was not married, and my parents, they did not have any idea about plutonium. Forget about, even they did not know what is BARs.
Okay.
So it was really exotic.